Okay, we're going to do more molecules and determining the absolute configuration. And so let's try it. I'm gonna give you this one. Let's say that I have, again, I'm gonna do this. And so let's assign priorities, right? I know this is a chiral center and it has 4 different constituents. So assigning priorities, we need to go and find the highest atomic number of the elements directly attached to the chiral center. And this is chlorine, highest atomic number. Go to your periodic table and find it. Now, of the periodic table, we know that the lowest atomic number is hydrogen. So that right there is my priority 4. And now I have a carbon and a carbon. So it is a tie. So we need to break the tie to determine. We know this constituent is different than that. That's a methyl, that's an ethyl group. But how do we do that? So I know this is a carbon. But this carbon is attached to another carbon. And here you know that this is, I'm going to draw it. That's a CH2, CH3. So what I have is that a carbon here is attached to another carbon and to hydrogen and hydrogen. So 2 hydrogens. See, again, this carbon is bound to a carbon and has 2 bonds to hydrogen. Now we go over to that side. And I'm going to do this. This is a CH3. So the carbon that's here, the carbon here is attached to bonds to 3 hydrogens. So we know that carbon, carbon, that's a tie. Now we're going to look at what's attached to it. And so let's compare that. Now, this is attached to carbon, and carbon has a higher atomic number. So this group, the ethyl group, has higher priority than this group. So we're going to assign here the number 2, and this is going to be my priority 3. I have my priorities, right? And again, if there is a tie, you need to see what's connected to that and go to the second layer. So first layer, you have carbon, carbon, but then in the second layer, you see that there's carbon and you the other side has a hydrogen, so this side has higher priority. Now, but I'm looking at that the wrong way because I need to have the lowest priority group away from my view. So what I'm going to do is what we did before. So we're going to do a rotation here, and that's an axe. And we know that if we do 180 rotation, let's do this. We're going to exchange what is on one side is going to go to the other side, right? And also what is in the back is going to go to the front. So we're going to change places here, and we draw our molecule again after the rotation. And when I do that, now I am going to have the hydrogen here, the chlorine, and now ethyl here, methyl here. See, we have changed the places of those. But priorities are still the same, of course. So we're going to say priority 1 is chlorine. The lowest always, check your lowest atomic number. And in this case, is a hydrogen. And in between those two, we know how to determine. It was a tie in the first layer, say. So we have carbon and carbon, but then when we compare the second, we break the tie, and this is second priority, third priority, and now what we do, we're looking at that the right way. So with the lowest priority group away from your view, now I can do determine the configuration following highest priority, then second highest, and so forth. So I'm going to go 1, 2, and 3, and now the configuration here, notice you're going counterclockwise, so that's S. And so what's important here is to know how do you break the tie when you have two groups that seem to have, they have the same atoms. So in the first layer is the same. So we're going to do more problems of these type in another video.